Hello dear students, welcome back to the second phase of online classes. In the first phase of online classes, the last class we have uploaded on mean deviation. Here I am going to upload that last class also on mean deviation, and today we are going to study the standard deviation. First we will study the definition of standard deviation. The positive square root of the mean of square deviations of given observations from their arithmetic mean is called standard deviation. It is denoted by a Greek letter sigma. The relative measure is known as coefficient of standard deviation, and it is given by coefficient of standard deviation is equal to sigma upon x bar, that is standard deviation upon arithmetic mean. Here we have to note that the square of the standard deviation is called variance, and variance is denoted by sigma square. Then we have the calculations of standard deviation. For ungrouped data direct method, sigma is equal to square root of summation x minus x bar bracket square divided by n. That is, sigma is equal to summation x square upon n minus summation x upon n bracket square. For the calculation, this second formula we are using. Then for ungrouped data by deviation method, standard deviation is sigma is equal to square root of summation u square upon n minus summation u by n bracket square, where u are nothing but x minus a and a are nothing but the positive constant. Then grouped data and discrete data. Direct method, the standard deviation is equal to sigma, which is equal to square root of summation f into x minus x bar square upon capital N. That is, sigma is equal to summation f into x square upon capital N minus summation fx upon n bracket square. Then by deviation method, this standard deviation sigma is equal to summation f u square upon n minus summation f u by n bracket square, where x is equal to x minus u is equal to x minus a. Then grouped data, that is continuous data. By direct method, sigma is equal to square root of summation f into x minus x bar bracket square upon n. The same formula whichever we use for discrete data and continuous data, but here x are the midpoints of the class intervals. That is only the difference between continuous data and discrete data. Then sigma is equal to square root of summation fx square upon n minus summation fx upon n bracket square. Here x values are nothing but midpoints of different class intervals. Then by deviation method, sigma is equal to summation f u square upon n minus summation f u by n bracket square, where u is equal to x minus a divided by c. Here a is the change of origin and c is the change of scale. Then we have some properties of standard deviation. The first property is, for any set of values, standard deviation, that is sigma, which is always greater than 0, that is standard deviation is non-negative. Then the value of the standard deviation remains the same if in a series each of the observation is increased or decreased by a constant quantity. That is nothing but standard deviation is independent of change of origin. Then third property of standard deviation is, for a given series, if each observation is multiplied or divided by a constant quantity, then standard deviation will also be similarly affected. That is, standard deviation is dependent on change of scale. Then we have one more property. It is the list of all root mean square deviation. That is, standard deviation is the minimum of all root mean square deviations. Then the last property of standard deviation is, that is combined standard deviation. Here let a set of n1 values have mean x1 bar, that is arithmetic mean x1 bar, and standard deviation sigma 1. Let the another set of n2 values have mean x2 bar and standard deviation sigma 2. Then standard deviation of n1 plus n2 values put together is sigma c, that is standard deviation of combined set sigma c is equal to square root of n1 into sigma 1 square plus d1 square plus n2 into sigma 2 square plus d2 square divided by n1 plus n2, that is the total number of observations of first and second samples, where d1 is equal to x1 bar minus x bar c, that is mean of first sample minus combined arithmetic mean, and d2 is equal to x2 bar, that is mean of second sample minus x bar c, that is combined arithmetic mean, where x bar c is combined mean, and we know that x bar c is equal to n1 x1 bar plus n2 x2 bar divided by n1 plus n2. We have studied under the properties of arithmetic mean. Then we have some merits and demerits of standard deviation. Standard deviation is based on all the observations. Then it is well defined by a mathematical formula. The next merit is, it is useful for further statistical analysis, and it possesses the sampling stability. These all points we have studied under the essentials of good measure of dispersion. Then demerits. It is difficult to calculate. Standard deviation is bit difficult to calculate. And one more is, it is affected by abnormal extreme values. Since it is based on all the observations, any values are too small or too big in the series, then standard deviation is too much affected by these extreme values. Then we have to study the coefficient of variation, that is CV. For comparing the variability, uniformity and consistency of two or more distributions, we calculate coefficient of variation, that is CV. Now coefficient of variation is the percentage of coefficient of standard deviation, that is CV, that is coefficient of variation is equal to standard deviation upon x bar into 100, that is sigma upon x bar into 100. Now here we have to note that lesser the value of CV, more consistent is the distribution. If value of CV is less, then the distribution is more consistent, and more the value of CV, less consistent is the distribution. If value of coefficient of variation is more, then distribution is less consistent. Now we will solve some examples on this standard deviation. These examples you can expect in the exam for 1 mark. First question is, if standard deviation is equal to 4 cm, find variance. Here given that sigma, that is standard deviation, is equal to 4 cm, and we know that variance is nothing but sigma square. Here sigma is 4, so 4 square, which is equal to 16 cm square. That is the variance for the given equation. Then one more question is, if variance equal to 16 square feet, find standard deviation. Here given that variance is equal to sigma square, and which is equal to 16. Therefore standard deviation is sigma, which is nothing but square root of sigma square, which is equal to square root of 16, and square root of 16 is nothing but 4, and the unit is feet. So standard deviation for the given data is 4 feet. So these examples you can expect in the exam for 1 marks. Now let's solve some 5 mark examples. Here the question is, find standard deviation of the following data, and here some values are given. Now in the solution, we have to consider these given values as x values, and then we have to find x square. So 25 into 25 you will get 625, 50 into 50 you will get 2500, and so on. For all the values we have to find the squares, and we have to add all the x values. Then you will get summation x is equal to 440, and summation x square you will get 21070. Then we have the formula. This, since it is a discrete data or ungrouped data, we will use the formula for standard deviation for ungrouped data. That is sigma is equal to square root of summation x square upon n minus summation x upon n bracket square. Here the number of values are 10. So n is equal to 10 here. Now by using n equal to 10, we will put the values. That is square root of summation x square is 21,070 divided by n is equal to 10 minus summation x is 440 divided by n is 10 and its square. Now if you simplify this 21,070 divided by 10, you will get 2,107, and 440 divided by 10 square, that is 44 square, you will get 1936, which is equal to square root of 171. And if you take the square root of 171, you will get sigma is equal to 13.0766. Now let's see one more question. Calculate standard deviation for the following distribution, and here the frequency distribution is given, that is discrete frequency distribution is given, x and f values. X equal to 4, variance is 6, x equal to 5, variance is 12, and so on. X is equal to 10, variance is 15. Now first we have to prepare the table. Given values we will write as x, then frequencies, then we have to find x square, square of x values, then f into x and f into x square. Now first we will find x square, that is 4 square you will get 16, 5 square you will get 25, 6 square 36, 7 square 49, 8 square 64, 9 square 9 square 81, and 10 square 100. After calculating these squares, we have to multiply f into x values. That is 6 into 4 you will get 24, 12 into 5 you will get 60, 15 into 6 90, and so on. Calculate 10 into 15 you will get 150. After that calculate f into x square, frequency into x square. 6 into 16 you will get 96, 12 into 25 you will get 300, 50 into 36 you will get 540, 28 into 49 you will get 1372, 29 into 64 you will get 1856, 14 into 81 you will get 1134, and 15 into 100 you will get 1500. After that we required total frequency, that is capital N. If you add these frequencies you will get 119. Then summation fx, addition of fx values, you will get summation fx is equal to 878. Similarly we required summation fx square, that is summation fx square is equal to 6798. Now by using these totals we will use the formula of standard deviation for grouped data discrete distribution. That is sigma is equal to summation fx square upon n minus summation fx upon n bracket square, which is equal to summation fx square is 6798 divided by capital N is 119 minus summation fx is 878 upon 119 bracket square. It is under the square root. Then if you simplify this 6798 upon 119 you will get 57.1261, and 878 upon 119 it's a square, that is 7.3782 square. Now 57.1261 keep as it is, 7.3782 square you will get 54.4371. After subtracting these values you will get square root of 2.687, and by taking square root you will get sigma is equal to 1.6398. Now students, one more video, as I told in the beginning, that is the last video from the first phase of online classes, that is the lecture on mean deviation, we will upload, and we will upload also today's lecture, that is standard deviation. Now you have to prepare both the notes, because in the online classes we have, even though we have completed the portion up to mean deviation, but in the offline classes in the classroom, we have completed the portion up to quartile deviation. So mean deviation was remaining. So because of that, the last video of first page online classes we are uploading for the mean deviation, and the remaining part from this analysis of univariate data, measures of dispersion, that is standard deviation, today we are going to upload that also. Now some more examples are there on this standard deviation that we will see in the next class. With that class we are going to complete the measures of dispersion, and then we are going to start the last part of this analysis of univariate data, that is moment, skewness and kurtosis. Simultaneously you people are studying the sixth unit. Madam is teaching that sixth unit, that is correlation and regression. You have to prepare the notes for that unit also. Thank you.